In this section, we're going to be working on expanding our original gameplay idea for jump jets into a more in-depth gameplay mode. The first thing we're going to do is to add in a toggle, then we'll expand it later by adding in a height target and the ability to pitch and roll. So, the first thing we're going to do is add in this toggle mode, and then we're going to clean up this section down here by adding in a function to take care of all of the fuel incrementing for us and hide it away from this main section of code. Now, as for the toggling, we no longer care if the button is being released, so we'll switch these cases. And what we do care about is whether or not the jets are already on. And we'll say if they're already off, then we will turn them on, and if they are already on, then we will turn them off. Now the problem here is that if this section of code is ever executed, it'll call jets on, and then when it gets here, the button will still be down, and now the jets will be on, so it'll turn them back off. Now, there's a very easy solution to this, which is to say else if. This way, only one of these will ever be run at any given iteration. The next part, we want to add in a fuel updating function. So we'll go in here, we'll add it to our class. It needs to keep track of the time, so we'll give it the parameter frame time. And back down in here, add it. And it's going to be more or less the same as this chunk of code right here. So we'll copy that over. And instead of jets run, it's going to take over this little section of code. We'll just copy that in, indent it. And now in here we can get rid of this else statement, which makes this function a lot cleaner. We still want to call jets off. This looks good. Now back up in here, we can get rid of all of this big chunk of code and just call jets run without having to worry about anything else. Before we call that, we'll call jet fuel update with the time. So in this next part, we're going to try and add in some steering to the vehicle. This will mean we can pitch and roll so that we'll be able to make that upward thrust we have push us in different directions other than just straight up. Now to do this, we're going to have to make it so that we have a target axis that we want to be aligned to, and we'll move by rotating that target axis and then letting some other functionality, much like our current controller is doing, try and align the vehicle's up axis to that target up axis. Now we can do this in a couple of different ways. We could modify our controller, we could create a new controller, but I think the best way in this case is going to be to do it all through functionality that we add to the Jeep class itself, or simply define as standalone functions in vehiclejeep.cpp. Now the first part of doing this is going to be taking out the old controller. Now to start with, we're just going to comment out these two functions so that we'll have to replace the orientation functionality. We'll worry about actually removing the controller's initialization later. Now the next thing we want to do is to examine how the controller is doing what it's doing. So we'll take a look in the simulate function in physcontroller.cpp. Now we see it uses some functions like get velocity, get position matrix, that are all through the iPhysicsObject interface, and then finally calls compute route speed to align axes to get its final answer. It also needs to know about the delta time or the frame time. So we have an idea now what we need, so we can copy all that functionality over into our jets run function. So first things first, we want a pointer to a physics object we're going to work on. We saw in the other function that was using this quite a lot, so we will set up ours so that we won't have to keep calling this big long function. We will replace this with our new pointer. Add in a little bit of commenting, make it easier to understand. That'll compute the linear component. And now we're going to add in our new chunk to compute the angular component. And we have our new angular impulse. We'll call it ang thrust instead of vec thrust. We'll pass it in over here. Now I've got to add in some stuff to set it up. The first thing we're going to want is to get our current velocity. We'll get our angular velocity. We'll use our physics object. And we'll give it a pointer to ang velocity. The next thing we're going to want to do is transform our target axis from world coordinates to local coordinates, and for that we'll need to get the position matrix. So we'll create our new matrix. World. Notice how I'm naming it a little more appropriately to its purpose than just matrix. Call p object get position matrix. Pass in a pointer. Now that we have that, we're going to have to figure out where we're storing our goal axis and where we're deciding what our local test axis is. Now, since our local test axis in this case is always going to be 0, 0, 1, we can just create it right here. Zero, 0, 1. Now, what's a little bit harder is our goal axis. Now, remember, the reason we're putting all of this into the Jeep is so that we'll be able to access them locally and change around our goal axis, allowing us to steer. So we're going to have to add in a new variable through vehiclejeep.h. And while we're at it, we should also remember that the compute function that we're going to be calling later requires knowledge of the time, so we'll need an extra argument for the jets run function. And then we'll add in our new variable. It'll be a vector in world goal axis. Save. Add it to our data description down here. And if we look, there's position vector, but we don't want a position vector. We want a regular vector. Vector. Save that. We will initialize it in our constructor over here. And we'll use the same initialization system we had for physcontroller.cpp's version of it, which is to say we'll just get the local up axis, which in our case we can simplify to just say it is equal to 0, 0, 1. Now then, back down in our run function. And we will create a new variable to store our transformed goal axis. We'll fill it with our inverse vector rotation to go from world to local axis. So in world goal axis, local to world, and finally local goal axis will store the result. Alright, that has us pretty much set up. So all that's left to do is set the angular thrust. And let's take a look at what the name of that function is. Copy it over, save us some typing. Our test axis is local test axis. The align axis is the local goal axis. Our current speed is ang velocity. Our damping, just like in the simulation function here, will always be 1.0. Our scale is going to be 1 over the time frame. Again, just like the version that we were using previously in the simulate function. And again, our maximum rotational speed will be g jet stabilize. Now, since both of the axes that we passed in were in the local coordinate frame, so will the result be. Now this is okay because add velocity takes in a linear component in world space and an angular component in local space. Don't ask why, that's just the way it works. So we'll save this, and then we will build and run. After we correct and pass in our frame time. Hit the jets, the toggle's working, we're stabilized just like we wanted to be, drops us back down, say that worked perfectly. Now that we've successfully replaced the functionality from the old controller, we can finish removing it. We'll delete these old statements. We will remove all references to it. Take it out of the data map. We don't need to initialize or create it anymore. And finally, we'll remove it from class itself. Save this, and with everything set, don't forget we've just reached a very stable benchmark, so we're going to do an svn commit again.